got some questions about this question specifically from week 5. It's about the calculation of continuum for previous example. Let us determine the cutting power and the specific energy in the machining operation if the cutting speed were given in meter per minute, summarizing that the data and results from the previous example were that the initial depth of cut was 0.5 millimeters, the width of the chip was 3 millimeters, and the cutting force was 1,557 Newton. So we just need to find the power. Now let's go back to the question, and we saw the parameter available. Let's go to the equations we have. We all know that the cutting, in the case of the linear movement, is going to be equal to the force multiplied by the velocity, and that's what we can see here. Now the units is going to be very important because we know that in general the power unit is watt or joule per second or Newton meter per second. So we need to know that the force here and the velocity should give us units of Newton meter per second. So for the force, it is already in Newton, and that's what we can keep it as it is. So we can see here that the force was 1,557 Newton. Now we need to change the velocity to meter per second. It's given to us here in meter per minute. So to change that, we need to divide that by 60. Okay, so that's obvious now. We can find the power. It's going to be equal to 1,557 multiplied by 100 divided by 60. So let's get this one sorry for that. Okay, so now we have all the information to calculate the power, and that's what we can see here. So here what he done is that he just calculated in Newton meter per minute, then he divided by 60 here and got the value to be 2,595 watts. Now we finished for the first part, and now we need to continue to find the value for the specific energy. Now for the specific energy is going to be about what will be the amount of the energy we are going to spend to remove a certain volume of the material during the cutting operation. Okay, so this shouldn't be something hard to think about. Okay, so is the amount of the energy required to be removed per unit time, and that's it. So you can see that the equation is going to be quite simple. First, we put here what will be the amount of the power in joule per minute, as it is. And below, we're going to put mainly the volume flow rate, or the amount of the volume to be cut. So that's what you can see here, that we have 3 millimeters, 0.5 millimeters, and 100 of meter per minute. Okay, and now we have meter per minute, millimeter per minute here, multiplied by the millimeter, multiplied by the millimeters. And we got here as cubic millimeter per minute. And thus we got the unit to be, the value to be 1.038 joule per cubic. This should be cubic millimeters. This one is not going to be cubic meters in all the cases. So just gave us what will be the amount of the energy required to remove 1 cubic millimeter of the material. So once again, go back to the equation. This will be the first equation I'm going to use. That's if we're going to have the efficiency, so we can get the value of the gross energy, because that's actually the power, the cutting power. But that's what we are going to apply actually on the part. But in real cases, we need to feed some energy to the motor. The motor is going to have some efficiency, and that's what we can find here. The gross power that need to be supplied to the motor is going to be equal to the cutting power divided by the efficiency of that motor. Okay, now the unit power, as we mentioned once again, is going to be the cutting power divided by the rate of the material removal. The rate of the material removal, which is, as we mentioned once again, the amount of the volume of the material to be removed during the machining operation. The equation is already been given here. It's going to be the velocity multiplied by the depth of the cut multiplied by the width, and above we have the power is going to be cutting force multiplied by the velocity. So that's it. I don't think that this question is quite complicated, and I still wondering why the people actually got missed out of it. I think this one is going to be actually more complicated because if you would like to understand how to do this question, you have to look at what we call it the sorry, that's not the equation. I just forgot the name of the equation. It's Crookes equation. So we just need to put the parameters exactly as they are. You need to check what are the units that we have here. So this one is going to be Newton meter per cubic millimeters or joule per cubic millimeters. The velocity should be put in here in meter per second. The depth of the cut should be done in meters, not in millimeters. The rho C is going to be in joule per cubic millimeters degree, and this value is going to be given unless we're going to be given the rho and the C individually. The K is going to be thermal diffusivity, and this will be in meter per square per seconds. Okay, so again, if I'm going to go to this question, as I told you, you need to put the units exactly as what we have it here. Don't try to change that because this will give you a different value for the increase in the temperature. Now, just remember once again, this is the increase of the temperature, and the final temperature of the part is going to be equal to this change plus the original temperatures that we have for the part itself, like 25 degrees. That is going to be at room temperature. Okay, thank you very much, and ready for any